Hello. So in this lesson, we are going to talk about diodes. So diodes basically are just controllers for currents in a circuit. So they control the direction on, they allow the direction of only one flow of current in a circuit. So let's briefly recall the reverse bias and forward bias. So for forward bias, you can have current, and you need to have a minimum voltage for our circuit to have a current. So for a reverse bias, you virtually have no current, and the setup for forward bias is that we have here positive and the negative side of the battery, and here we have the P and the N. So this is forward bias, and for reverse bias we have P and N, and our battery is reversed. So now let's talk about how diodes perform with these kinds of setups. So the symbol for a diode is a triangle here and a line here. So can you guess the direction of the current that this diode allows? So this triangle pointing to the right actually allows a current in this direction. So if we have a symbol like this, we have talked about the built-in electric field and the built-in voltage drop in the PN in the depletion region. So if we have here an electric field pointing in this direction, this must have a high potential in this direction and a low potential in this direction. So there is actually a voltage drop in this diode, so it can act as a resistor too, wherein in the sense that it consumes a voltage drop when you pass a current through it. So let's simplify a forward and reverse bias in terms of this diode diagram. So when we have a battery like this, so this is a forward bias, and we need to have a minimum voltage before this circuit conducts a current. Now for reverse bias, so I actually lied to you. This reverse bias configuration can actually conduct current at a very high voltage. So I said that it cannot conduct current because it helps the electric field inside the depletion region. But actually, if our applied voltage is so large and it's enough so that the charge carriers can now actually pass through the depletion region, that is called the breakdown voltage. So let's try to see in a graph how current inside a diode circuit responds with respect to applied voltage. So for example here, we apply a voltage. For example, here we have 0 voltage. So no battery. So of course, there will be no current. So as we increase the voltage in the circuit, the diode acts as an insulator and stops the flow of current inside the circuit. So there's a point in which, for example, we have 0.7 volts. There's a point in which the depletion layer is now gone, and the diode now can allow current to pass. So now current will suddenly be present inside the circuit. So this is y-axis is current. So now let's try to look into this kind of configuration. So here I forgot to mention the direction of current is the direction of voltage applied here is positive. So this region is called the forward bias region. So when we reverse the direction of the potential difference, so we apply here now. So there will come a point, this is very far, there will come a point that there will be a current now present inside the circuit. So now this point is the breakdown voltage, and this region is the reverse bias region. So normally in the forward bias region, diodes operating in the forward bias region are commonly LEDs or light emitting diodes. Now you might wonder, if we apply enough voltage in the reverse bias region, it can actually conduct electricity. So there are some diodes that apply this configuration, and an example of it is the Zener diodes. So Zener diodes use this breakdown voltage in their designs. So these are diodes, and diodes are basically composed of a p-type semiconductor and an n-type semiconductor with a depletion layer in between.